Today we'll discuss about the relationship between rainfall intensity, duration of rainfall, and frequency of rainfall. So frequency is represented by the return period, and as you know, return period is inversely proportional to the probability of the rainfall. Intensity is rainfall intensity. The unit is in centimeter per hour, and duration d is the unit is hour. Unit of return period is year. So here we will try to find a relationship between intensity I, return period t, and duration d. The relationship states that I is equals to k into t to the power x divided by t plus a to the power n. Here x, k, a, and n all are constant, which varies with catchments, and the relationship of depicts that intensity of rainfall is directly proportional to its return period. That means more the return period, more will be the intensity, which also implies that a high intensity rainfall is rarer compared to the low intensity rainfall. So this is one relationship, and also it states that this equation states that the intensity of rainfall is inversely proportional to duration of the rainfall. So that means a long duration rainfall will have a lower intensity, and a short duration rainfall will have a higher intensity. So this is what the intensity, duration, frequency relationship. Now for example, how to calculate intensity of rainfall from this equation. What will happen is, in case of numerical problems, we will give you the range of rainfall or rainfall intensities, and from the range of rainfall you have to find the return period, and also the duration will also be given. Duration of rainfall will also be given. Then you apply the duration and return period to find the rainfall intensity. So let us take an example for this. So suppose 5-year rainfall is given along with its duration. Now, what are the 5 years rainfall? For example, in 2022, let me say the average rainfall of 2022 is 125, and average duration of that rainfall is, say for example, 3 hours. Then in case of 2021, 100, this is also 3 hours. Then for 2020, 90, this is also 3 hours. Then 19, this is also 3 hours. Then 18, 95, and this time it is 5 hours. So your first step will be is that all the duration of rainfall must be will be equal, or rather, okay, before that let me say what is the question. Question is, what is the rainfall intensity? The question is, what is the rainfall intensity for all these rainfalls? Okay. Okay. So what is the rainfall intensity of all these rainfall? It's very easy. If you use the previous equation, I equals to, you see, I am talking about this equation, K into T. I equals to K into T by D plus A to the power N. I is equal to K into T to the power X by D plus A to the power N. Here, as you know, K, X, A and N all are constants which varies with catchment. So another thing that the problem must state or must include is the values of all these constants. So suppose I say that K is 1, X is say 3, A is 0 and N is suppose let it be 1. So for different catchment, for one catchment this is the values. If there are more catchments, then different values will be given. Now this constant value or these values of the constants in real life, they were calculated by the Central Water Research Institute CWRI for each and every basin of India for specific intensities of rainfall, specific duration of rainfall and specific level of rainfall. So basically ISO height lines are drawn based on the rainfall data of different catchments all over the India, and based on those isohedral lines for starting from 15-minute duration, 30-minute duration, 60 minutes or 1 hour duration, then 3 hour duration, then 6 hour duration up to 24 hours duration, different curves were drawn for different intensity of rainfall which are represented by the different isoheight lines. And after then they, in the same equation, they put the values of the return period, values of the duration, values of intensity to find the value of K, value of X, value of A, value of A. Just the inverse to this problem. But in your case, in this case, in your problem, this K, X, A and N will be given. The rainfall intensities will be given, average rainfall, duration of the rainfall will be given, and you have to find out the rainfall intensity based on the return period of all this rainfall and duration of all this rainfall. Here I have made a mistake. This cannot be average rainfall, let it be peak rainfall, because in this case individual rainfall event has to be constant. So in the 2022 the peak rainfall was 125 millimeter, which has a duration of, this also will not be average duration, this will be only duration, which have a duration of 3 hours. This, what is the intensity of this rain? Correct. Then 100 millimeter is the peak rainfall, which have a duration of 3 hours. So what will be its intensity? I. So how to calculate this problem? So it is very easy to calculate. Your first step will be to find the probability of all these rainfall. And how we will try to find the probability of all this rainfall? So how we will try to find the probability of all this rainfall? By applying the Weibel's formula that I have discussed in the earlier presentation. So here, as you know, let us again write the rainfall. These are the years. Okay, rainfall is like 135, 125, 190. This will be 125, 190, and 105, 95. So let us return 105, 95. Now arrange them in descending order of magnitude. That means the highest magnitude will get the best rank, lowest magnitude will get the worst rank. Among these 5 rainfall events, this one will be first, this one will be the 5th, and this one second, this one third, and this one fourth. Now apply the Weibel's formula. Weibel's formula states P is equals to m by n plus 1. Here m is the order or rank of the rainfall. So in the first case 125 millimeter, rank is 1. So 1, here 5 number of data points is there, 1 by 6. So we calculate 1 by 6. So it will be, I think, let me use the calculator. That way. So 1 by 6 is 1 by 6 is your 0.17 or 0.166. So let it be 0.17. Similarly, for this one, this is m is 3. M is 3, rank is 3. So m3 by 5 number of rainfall, 6. It is coming half. There was 3, 1 and 2. So it is actually 0.50. Then 5. So m is 5. 5 by 6. So it will be like 0.83. And the last one is 4 by 6. So it will be 2 by 3. So it will be 0.67. Okay, so these are all probabilities as usual. The most extreme or the event with the highest rainfall is rarest, and event with the lowest rainfall is commonest. Correct? The lowest rainfall has a probability of 0.83 and the highest rainfall has a probability of 0.17. But in our case, return period is important because to calculate rainfall intensity, we have to find the return period. Correct? So this is our formula. So these return periods need to be calculated. So for the first case, you see P is 1 by 6 and 1 by P is T. As you know, T is actually 1 by P. So this 1 by 6 will be inversed and our T will be 6. So for the first event, T is 6. For the second event, that means which is the position of third, this one, T will be 2. In case of third event, T will be, so it is 0.83. So it will be 1 divided by 0.83. So it will be 1.2. Correct this one, the fifth one. Okay. And for the after then second position, the storm with or the rainfall which have a position 2. So what will be the return period? Return period will be 2 by 6. 6 by 2, it will come 3. This is second position. Weber's formula states P is equal to m by n plus 1. Here m is 2, n plus 1 is 5 plus 1. So it is 2 by 6. To calculate return period, you have to inverse it. So it becomes 6 by 2. So 3. Now lastly, the fourth position, rainfall is the fourth rank. It is 4 by 6. That is 2 by 3. That means for to calculate return period, it will be inversed. So T will be equals to 3 by 2, which will be equals to 1.5. So as you see, it has a return period of 1.5. So I think it is very easy to understand that the rarest event has the longest return period. So this longest return period. Okay, so that is why it is 6 years. So this is the event of 2022, which has the first position. Then the second position, that means the peak rainfall of 2019, 105. So it will have a return period of 3, right? So this is the position brought by 2019, 3-year return period. Then followed by the third position, which will have a return period of 2 years, correct? And then this one, the peak rainfall of the year 2018, has a return period of 1 point, has a return period of 1.5. So this will be a return period of 2018. And lastly, the rainfall is the lowest position, that has a return period of 1.2. The rainfall occurs in the year 2020. Right, so you got the return period. Now I will just show you the how to calculate rainfall intensity from this equation for only one event. The event which has the first position, that means which has a return period of 6. So let us see. So I, for the peak rainfall of 2022, is K into T is, as you know, is 6 to the power x divided by D. D is already given, 3-hour duration, as you can see here, 3-hour duration. So D will be 3 plus m to the power n. Now let me see in the problem, the values of the constants are already given, k, x, a, n. So put it down in the equation. You see k is actually given as 1. So this and x, actually k into 6 to the power x is in the numerator. So k is 1, x is 3. So put it like this, k is 1, 6 to the power 3. So we put it in the calculator, what it is coming. Let me use the scientific calculator, that it will be easier to calculate. K is 6 to the power x. So let me say 6 to the power 3. Six to the power 3, so basically 6 cube. Correct. 6 to the power 3, 216. K is 1, Okay, so k is 1 and 6 to the power x is 3, so 1 into 6 to the power 3. So the numerator becomes 260. Numerator become 216. Now let us look into the denominator. Denominator d is 3 hour duration, so 3 is given plus a in bracket to the power n. So what is a and n? A is 0, n is 1. So a is 0, n is 1 as per given here. A is 0, n is 1. Correct? So what is coming in the denominator is 3 plus 0 to the power 1, that means 3. So 216 divided by 3. So the rainfall intensity is 72 millimeter per hour. Correct? Okay. So I is 2022, rainfall intensity is this. So similarly, you can calculate the rainfall intensity of 2021, 2020, 2010, 2018 with the help of its return period, with the help of its durations. All the durations are given here, and these constants a, x, a, n. Now, if I calculate another, they show you the intensity of rainfall for another event that we take to the second position. That means this one, 210. This, sorry, the year 2010, rainfall 105 millimeter, and this will be your second position among all the 5 rainfall given. So this has a duration 2019 event. So we will find the rainfall intensity of the peak rainfall of 2019. This is not 2010 but 2019. The amount of rainfall was 105 millimeter and the duration was 3 hours, and this rainfall has a position second among all the 5 rainfalls given in the problem, and hence it has a probability of 0.83 and corresponding return period as 1.2, right? Sorry, not 1.2, it is 3, corresponding return period of 3, because it has a position of 2 divided by 6, this is your p, 1 by p, the return period is actually 6 by 2, 3, correct? So it has a return period of 3 hours. Now we will put it into the equation. I for 2019, k multiplied by t to the power x divided by t plus a to the power n. Now where k is given as 1 and x is given as 3, d duration plus a is given as 0, n is given as 1. Let's see the problem. K is given as 1, x is 3, a is 0, n is 1. Now, as I know, for the 2019 rainfall, the return period is 3. So this becomes this 1 into 3 to the power 3. The duration is 3. As you know, the duration is 3 plus 0 to the power 1. So it becomes 9 by 3. So the rainfall intensity becomes 3 millimeter per hour. Right? So similarly, you can calculate the rainfall intensity of other three events also. So it is very easy. First, find the return period. This is the first step. Step one is find the t, correct, by the help of 1 by p, where p can be found out by Weibel's formula, correct, which is that Weibel's formula, m by n plus 1. M is the rank or order of rainfall when all the events are arranged in the descending order of its magnitude, correct. First step. Second step is, so find what are the value of k, x, a and n. This will be given in the problem, and also note the duration, which will also be given for each of the rainfall duration t. And then in this equation, I is equal to k into t to the power x by d plus a to the power n. Put the values of the constant, put the value of return period as you have calculated here in the first step. Duration is already given in the problem. Put that duration, corresponding duration, and you will find the intensity of rainfall. This is what you have to do to calculate the intensity of rainfall from return period and duration of that rainfall and these four constants. Thank you.